Hackers often need to multiprocess, and an operating system like Kali is ideal for this. The hacker maybe have a port scanner running while running a vulnerability scanner and an exploit simultaneously here. So this requires that the hacker manage these processes efficiently to best use system resources and complete the tasks. In this lecture, I will show how to manage multiple processes. So changing processes priority with nice. You don't often hear the word nice used in the context of hackers, but where there you will. So the nice command is used to influence the priority of process to the kernel. As you saw when we ran the ps command here, numerous processes run on the system at once, and all of them are contending for available the resources. The kernel will have a final say over the priority of a processor, but you can use the nice to suggest that the process should be evaluated in priority. So the idea behind the use of the term nice is that when you use it, you are determining how nice you will be others users. If your process is using the most of the system resources, you aren't being very nice. The values from nice range from minus 20 to plus 19. So with 0 being the default value here. Default 0 here. So a high nice value translates to a low priority, and the low nice value translates to high priority. We are not being so nice to the users and other users and processes. So when a process is started, it inherits the nice value of its parent processes. So the owner of the process can lower the priority of the process, but cannot increase its priority. Of course, the super user or root user can arbitrarily set a nice value whether they please. So when you start process, you can set the priority level with the nice command and then alter the priority after the process has started running with the renice command. Renice here. So what's the absolute value for niceness? So let's look at an example demonstrate this. So for demonstrating purposes, let's assume we have a process named slow process that's located at being slow process here. So if we want it to speed up its completion, we could start the process with the nice command here, nice -n -10 bin slow process here. We should use sudo rights here and enter your password here. Slow process no such files because this I did just an example here. So the command will increment the nice value by -10, increasing its priority and allocating it more resources. On the other hand, if we want to be nice to our fellow users and cases and give slow process a lower priority, we called increment its nice value positively by 10. So give this try on a process you have currently running and then run ps to see how it changes if now. So changing the priority of running processes with renice. So the renice command takes absolute values between -20 and 19 and sets the priority to that particular level, rather than increasing or decreasing from the level at which it started. In addition, renice requires the process ID of the process you are targeting rather than the name. So if the slow process is using an inordinate amount of resources on your system and you want to give it a lower priority, just allowing the other processes a higher priority and more resources, we call renice slow process, not by name, which is, for example, for the process ID, for example, 699 naps, for example, renice 12. 69996, for example. This is the process name, for example, but it's 69996. So as with nice, only the root user can renice a process. As you can see, if I need to get priority, no such process here, but we can use sudo. Yes, this is not a such process here. So as with nice, the only root user can renice a process to a negative value to give it a higher priority. But any user can be nice and reduce priority with renice. So you can also use the top utility to change the nice value. With the top utility running, simple press the R key, R here. Oops. Let's run it again, and simply press the R key here, and then supply the process ID and the nice value. For example, if I want to change a process ID of Metasploit here, as you can see, there is a running here, or just for example 6 here and nice with 12, unacceptable integer because the nice is maximum, for example 6 8 here. So now I will show you the killing processes. At times, a process will consume way too many system resources, exhibit unusual behavior, or at worst freeze. A process that exhibits this type of behavior is often referred to as zombie process. So for you, probably the most problematic symptom will be waste resources used by the zombie that could be better allocated to useful processes. When you identify a problematic process, you may want to stop it with the kill command here. There are many different ways to kill a program, and each has its own kill number. So the kill command has 64 different kill signals. So, and each does something slightly different. So, for example, I want to write this here in mousepad, notepad here. So, signal name, for example, I will the most important signal names. So if you don't provide the signal flag, it defaults. If you don't provide if you don't provide signal flag, it defaults to sig term. So we have a signal name and I want created here. So sig hub, for example, signal name number for option and description here. So sig up here, number of option is 1. So hang up signal. So it stops the signal processes and restarts it with the same process ID. Restarts same process ID. So restarts with same process ID. So we have sig integer here, interrupt here, not integer actually. Number for option is 2. So this is the interrupt signal. So it is a weak kill signal that it's guaranteed to work, but it works in most cases. Weak signal, but works actually, but works here. So we have a sig quit here. Number of option is 3. So this is known as the core dump. Core dump here. It terminates the processes and saves the process information in memory, and then it saves this information in the current working directory to a file named core. Decisions for doing this are beyond the scope of this course, but you will learn in later lectures. So we have sig term here. Number of option is 15. So this is the termination termination signal. It is the kill default signal here. Oops. Here. And lastly, I want to show you is sig kill. So sig kill is using number for option 9. So this is the absolute kill signal. So it forces the process to stop by sending the process resources to a special device, div null. Absolute kill signal, and so very serious here. And using the top command, you can identify which processes are using too many resources. Often those processes will legitimate, but there may be malicious processes taking resources that you will want to kill here. Let me look at our lecture time here. So if you just want to restart a process with hoop signal, enter the -1 option with kill here. For example, kill -1. Kill -1. Actually, let's use kill Metasploit here. Let's find this PS aux here. Where is the Metasploit here? Metasploit. Actually, let's find it with grep here. PS aux here, and grep msf console here. So our process ID is 1907. So we can kill it with it. Actually, it's Rabi 1671. So kill -1 1671. As you can see here, our Metasploit is killed. So clear. In the case of the zombie or malicious process, you likely want to send the kill signal 9. So this is the absolute kill signal, and it's very serious. With this kill -9 and process name, process ID here, like that, but with -1 here. So if you don't know the process ID, you can use the kill all command to kill the processes. This command takes the name of the process instead of the process ID as an argument. For example, kill all -9 zombie process. That's no process found. So finally, you can also terminate the process in the top command here. Simply press the key and enter the process ID like that. So I will close this here. So we can run Linux, run processes in background of Linux as well here. Actually, how many minutes we have? So you will learn this in next lecture. So I'm waiting you in next lecture.